Dear friends, welcome to Infos. Welcome to another video from oil and gas training. In this video, we are discussing about the flare system part 2. In fact, we have completed flare system 1 in our last video. Uh, in this video, let us discuss the various other equipments and system associated with the flare system. uh, One of the important item is a flare knockout drum. See, flare knockout drum is a or we can call port or vessel are a key component of the flare system, are used to slow down gas flow by creating a pressure drop, allowing liquid and condensate to fall out from the vented gas stream ahead of combustion in the flare system. See, so the entry is here like that one, whatever the released uh, gas or other systems are coming, entering to the knockout drum prior to going to flare system. So it is entering here, and whatever the liquid and other condensates are settling here, and the dry gas, maximum dry gas is going to the flare system. So the preventing that one liquid not allowing to burn there. Many reasons are there. Let us discuss that one by one later. So this is the knockout drum. So the function of knockout drum is to remove maximum liquid from the fiery gas. So simply we can say in this way. Primary duty to separate bulk liquid from gas, to limit liquid droplet size entrained with the gas to flare. So to provide adequate residence time for liquid. So it will keep the gas will keep here inside for a moment. Then by that time reducing the pressure little. So liquids can collect here and gas is releasing to flare system. So we can make sure that maximum liquid can remove from gas stream, released gas stream, and dry gas is flaring there. No liquid is going to flare. One of the reason is incomplete combustion. If you write the combustion reaction, CH4 plus O2, so it will give CO2 plus H2O. That is the reaction. So extra oxygen we are providing from air, but the liquid is there means it will very high chances are there to complete incomplete combustion. What is incomplete combustion? So forming of a carbon monoxide, CO, instead of CO2. So this is the one of the reason we are making sure that one all liquids are removed. Of course, the liquids means it's oil, so related to cost also we can say. So these are the or other many reasons are also there. Flare knockout drum design you can see here from here. Based on API RP 521, that is for the design people, mechanical people, it is mainly, or process engineers. Stokes law separation of liquid droplet size of 300 to 600 microns considering the design case of the flare. A Stokes law is our liquid droplet size, fluid mechanics we are studying that Stokes law. 20 to 30 minutes of liquid hold up time based on a relief case that results in a maximum liquid. 20 to 30 minute residence time. No internal to facilitate separation and to eliminate potential blockage. No internals are there. Normally other knockout drum and other separator scrubbers are facilitating with many other mechanical internals, helping that one better separation, but here no internal to facilitate separation and to eliminate potential blockage. Many orientation option possible. The best way is horizontal KOD, most preferred for considering as a flare knockout drum. Liquid removed by flare pump. Whatever the liquid is collecting here, Normally a flare knockout drum pump is connecting here. It will be working as a auto system because the level is increasing, pump will start. The released liquid, collected liquid level is decreasing, then pump will automatically stop. That is the normal practice. So these are the design aspect of a flare knockout drum. In flare knockout drum, we can do some gas recovery as well from the flare knockout drum. Before the flare going to flare, in fact, we can collect all the gas from the knockout drum and go to the gas holder. Then it can send it to a recovered gas system. That is the mission we are doing, or based on the vision we are doing zero flaring. We have to minimize flaring as much as possible due to environmental constraints and wasting of the hydrocarbon, energy wasting. So many other reasons. All companies are developing new way to save more and more flaring gases and recovering flaring gases, and concept of zero flaring introducing into the process industry. The process involves capturing the gas from the flare knockout vessel and compressing it using liquid ring compressor. So when the flaring gas is entering to knockout drum, instead of going to flare system, we can collect at least some quantity of gas to gas holder or directly to compressor, or gas holder and compressor. Then that gas is compressed and using as a recovered fuel gas system to various other applications. So FGRS fluid gas recovery system is typically operated at a slight positive pressure to prevent air infiltration into the system that could create a flammable mixture. So that is the concept of a recovery system. Prevent when gases are removed from the flare header, gas compressors boost the pressure of this gas. Recovered gas is discharged to a service liquid separator. One of the other important item is seal drum, flare seal drum. So after the knockout drum, the gases are moving to flare, but before it is entering to a seal drum. Then seal drum only the gas is releasing to or moving to flare stack. Then ultimately it is entering to flare tip. So let us see that one. What is seal drum? Water seal drum offers protection or additional to purge gas flow against atmospheric air ingression into the flare header through to the tip. So in case any setback is there, the flare gas or flare or atmospheric air will not enter back to the our process system, that is making sure a seal drum. So water seal drum offers protection additional to purge gas flow against atmospheric air ingression. It is entering back to the flare header through the tip. Mentioned air ingression could be created after a hot gas discharge when header is getting cool, could result in an explosion in the header containing flammable gas. Or in this flammable gas line, maybe a hot flare gas or hot air is entering, so it can create a explosion. So to prevent that one, we are using a seal drum. Normally water will be as the sealing liquid. Primary duty to prevent flashback from flare tip back to the flare headers, to avoid air ingress into flare system during sudden temperature changes, and to maintain positive system pressure. See, so prevent flashback. So that is the primary duty from flare tip back to flare header. So here flare tip to back to flare system. Then to avoid air ingress, air will not go back into the flare system during sudden temperature changes, and to maintain a positive system pressure. Design specification. Water as liquid sealing fluid, not recommended, or extremely cold releases. Water glycol mixtures of sufficient concentration using instead. So water can use in summertime, but water glycol mixture preventing freezing issues. We are using water glycol mixtures in seal drum. This is the one of the large pictures of seal drum. See, you can see that one flare gas is inside the water and gas is escaping from that one. So water level is always maintained above the flare gas inlet inside the vessel, and the flare gas is leaving the water seal drum with the gas alone, and this water seal is always preventing any air ingress or extra air backing flashback inside the flare header in this upstream side. A water seal drum can have various applications: prevent the air infiltration, act as a flame arrestor. See, one more important use is a flame arrestor, act as a staging device between multiple flare, provide back pressure to flare gas recovery system. See, many applications. Performance features you can discuss. It operates as a non-return device, preventing interaction from the outlet to the inlet of the drum. It operates as an upstream pressure relief valve, preventing gas flow from the inlet to the outlet until a particular upstream pressure, frequently predetermined, is reached. It acts as a divisionary unit for ground flare to elevated flare. Various other atmospheric flares is ground flare and elevated flare system. Ground flare to ground flare system, elevated flare to elevated flare system, fuel gas recovery system as to system to elevated flare. So it is acting as a divisionary unit for other some of the atmospheric flares. Flare tip smokeless operation. The apparent density or opacity of smoke is defined as the Ringelmann number, where 0 is a clear air and 5 is totally opaque. A low Ringelmann number is easier to achieve for a sonic or HP tip, means high pressure flare tip, and a header to achieve a pipe type or LP tip. So low Ringelmann number means it is using a complete combustion indication. 0 is a clear air, or 0 to 1 will be the indication of a perfect or complete combustion. Normally flares are some emergency situation flares are producing incomplete combustion. So the flare tip design will be always make sure that one the complete combustion take place in preventing formation of carbon monoxide in the air. Most applications specify a Ringelmann number 0 to 1, means it is almost clear or complete combustion. This can be hard to achieve at low flare rate, and therefore steam or air can be injected to reduce the smokiness. So this is sometime in low flare system it is difficult to achieve, so we are compressed air or steam injecting for achieving this target, complete combustion. Various type of flare tip design this area, the flare tip design, various type of tips. Flare tips are available depending on the location and specific design requirement. Sonic flare, another name is Conda flare for high pressure flare system. Pipe type subsonic, very normal pressures and low pressure or atmospheric pressure. Combination flare and steam or air assist flare. These are the main flare tip designs. Let us see one by one and what are the features and the constructional details available. Sonic flares are usually employed for HP system. See, high pressure flare, it is high pressure gas release. Sonic flare normally using where the available pressure is high. The emissivity factor or F factor of a sonic flare is between 0.07 to 0.15, is generally much lower than a pipe type flare, resulting in reduced radiation level for a given gas rate and therefore a lower flare stack. Yes, emissivity is the fraction of heat generated at a flare tip that is radiated to the surroundings. So it is a fraction of heat. Emissivity is a fraction of heat generated at a flare tip that is radiated to the surroundings. So pipe type flyers are usually employed for LP system. See, so conda flyer for HP flyers and the pipe flyers are for LP, low pressure system, where available pressure is low. Typically a factor of a pipe type is between 0.2 to 0.35. So conda flyer it is 0.07 to 0.15 and LP flyers are it is 0.2 to 0.35. This is the picture of the conda flyer. See, it is a different type of design. It is conda flyer tip. This flare system incorporates the conda effect which takes place when a gas jet is passed over a carefully profiled curved surface, creating a vacuum. This effect enables substantial amounts of air to be drawn into thoroughly mixed with the gas flow, resulting in combustion. See, it is using a conda effect. So based on that one, thoroughly mixing or better mixing and a better combustion for high pressure system. So see a curved surface creating a vacuum. The tip is specifically designed to achieve very low radiation and directional flaring while still meeting acceptable noise level. These are the advantages of conda flare. They typically operate at a pressure of 5 bar G and provide a good reliable method for high pressure gas disposal, whether by venting or flaring. So it is absolutely best for good for high pressure system. Another one is pipe type flare, mainly using for LP flare. This is the simplest type of flare tip, consisting of a cylindrical fabrication from which gas exits. It has a flange at its lower end that in turns connect with the flare riser pipe flange. Here you can see here it is, and this is a flare tip arrangement. The design, although are very robust and reliable, they are usually with smoke is allowed or gases to be flared do not produce much smoke, such as methane, hydrogen and hydrogen sulfide or carbon monoxide. See, I told the earlier in incomplete combustion, see carbon monoxide forming and other SO2 also much forming. So it is reducing that smoke in open pipe type flare. Open pipe flare tip can be used with steam injection. Earlier discussed that one, combination flare or air assisted flare or steam assisted flare, which reduces the smoke emission and radiation level. See, when the steam is injecting, or it can be used with the high pressure gas injection, which improves the air gas mixing at the root of the flame pipe flare tip to further reduce normal radiation. See, so various other combination also available to minimize smoke emission or radiation level, etc. Radiation level, etc., etc. Air assisted flare. These are the one of the available picture is air assisted flare tip. This tip achieves clear combustion, that means complete combustion through the injection of primarily air into the base of the flame with the help of an electrically driven fan or blower located at the grade. Normally in the flare system we make sure that one complete combustion, how it is achieving, we will supply or extra air, almost double extra percentage of air or excess air supply, make sure that excess air should be there in flare system to make complete combustion. If you write that combustion reaction, it is 2O2, CH4 plus O2 giving CO2, that is and H2O. So to balance the equation, we have to give excess air. So you can just search in the Google that one combustion reaction, balanced combustion reaction. So whenever we have to provide an excess air to make sure that one the combustion is a complete combustion. Combustion efficiency of a flared gas is increased by installing air blower, which will reduce smoke formation. Air assisted flare tip incorporates a design that splits the waste gas stream into several smaller streams at the top of the flare to increase gas air contact surface area and promote better mixing. And one more type of flare tip design is there, multiple flare tip. Look, you can see here, multiple flare tip. The initial flaring, maybe one or two flare will work or start firing, then or flaring, and then when more releases are coming, it can increase the number of flares in service. That method also possible here. Instead of a single burner, as on in other low pressure flare system, used multiple smaller diameter burners, provides improving mixing by splitting the gas and air into smaller unit. This improved mixing reduces the mixing path and result in a shorter, broader flame. The more efficient combustion of multiple tip results in lower smoke emissions and radiation levels than a comparable single tip. So multiple tip systems are there. This also reduce platform radiation level and the length of the flare supporting structure based on compare in offshore flare system. Another one is a molecular seal. You can see in the picture here, and a purge reduction seal, a seal system near the flare tip. The molecular seal is located just below the flare tip and is designed to prevent the ingress of air into the flare stack at the low flow rate. So it is a particular reason is there to provide this air or molecular seal system to prevent the ingress of air system or reducing the purge system. The molecular seal is minimizes the amount of continuous purge gas usage. So wasting of gas is minimizing. Gas normally flowing an upward direction and is turned through 180 degree to the direction of flow. So it will go here, then coming here, and a object is here, and it will go like this here. So it is always minimizing wastage of gas. Gas lighter than air will tend to collect in the upper bend of the ceiling of the stack against the backflow of air. So air will not enter anyhow, it will not enter here. Heavier gases will tend to settle in the low bend. A small continuous bleed of gas must be maintained to ensure that air does not penetrate to the seal, to maintaining positive pressure, else air will enter back here. So a small continuous bleed of gas must be maintained to ensure that air does not penetrate into the seal. A drain connection is required in the base of the outer cylinder here in this area for the removal of any accumulated liquids. So drain system also there. One more seal system is there. It is calling a velocity seal. Let us see what is that. The velocity seal works on the premise that when air infiltrates to the flare tip, it tended to hug in the interval of the flare tip here. The velocity seal is a cone-shaped obstruction, a piece of material placed inside the flare tip. So the obstruct the infiltrating air from hugging the inner wall. So it is obstruct. Purge gas is coming through the cone, sweeps away the infiltrating air. This seal normally reduces the purge gas velocity through the tip to between 0.006 meter per second to 0.012 meter per second and maintain the oxygen level below the seal under 4 to 8 percentage excess. So it is making sure that one excess air is always supplying, and it is air filtration infiltrates the flare tip, and velocity seal is preventing that one the air is flashback to the flare system as well, maintaining OI's oxygen level. However, the normal purge gas requirement prevent burn back of the flare tip is much higher than this. Flare stack design consideration, the stack itself various consideration design construction designs are available. Radiation, limit radiation, either continuous and peak on off site properties and persons, equipment, buildings and personnel on the installation applicable to impacted area, restricted area and equipment layout. Flammable gas also we have to minimize the radiation in the flaring system. Flammable gas, avoid ignition of a flammable gas cloud released from a cold vent or in case of flare flame out. Toxic hazard and gas dispersion, mainly H2S and SO2, but not limited to limit the risk of a toxic gas cloud to reach off-site population, means incomplete combustion gases are releasing. So in that case, chances of H2S forming is very high, toxic gases. So it will reach a populated area, then provide means of alarm and adequate protection to personnel present in the restricted area in case a emergency situation arises. Noise, limit both continuous and peak noise. Noise we have to minimize. So radiation, flammable gas escape cloud forming, toxic hazard gas cloud forming, noise issue. So these issues are we have to address in flare design and operation. Stack height is determined by HSE group based on the permissible radiation level as per the philosophy okay, 1 minute, let me flammable gas, avoid ignition of flammable gas, avoid flammable gas cloud release from a vent in case of a flame out. Stack height is determined by HSE group based on a permissible radiation level as per project philosophy of or API 521. A taller stack will result in a smaller sterile zone. This available sterile area generally sets the flare stack height requirement. And onshore flare options are available, various options are available in onshore flare stack options. One is enclosed flare, you can see here it is not much height but it's enclosed type, using mainly for atmospheric type flare, low pressure and atmospheric type flare. The flare is surrounded by an enclosure, reduce external noise and radiation, suitable for low and medium gas flow. And open ground flare is not much height, it is open ground flare. So it is open ground flare, gas and liquids are released to flare on the ground, surrounded by radiation fence. See, radiation fences are there, suitable for large gas flow. You can see here, not much height. Another one is vertical elevated flare. more cost effective than ground flare, which are expensive to build and service. Also require less ground flares as the flame is elevated, reducing ground level radiation. So it is elevated flare. Ground flares are equipped with several stages of burners, each set at a different pressure. As the flare gas rate is increases, the flare tip back pressure increases, more burners open up. In ground flares, it is a number of flares, multiple flares are there. So in the low flow or low flaring time, number of flares are less in service, and when the flare gas rate is increasing, more flare tip taking to the service. And offshore flare concept is also options are available. Enclosed ground flare only rely on suitable low flow rate, not often installed in offshore. So offshore, that is ground flare cannot possible to install there due to their construction or design issues. Vertical stack or inclined boom, these are the generally the flare arrangement in offshore system. The type of stack elevated will depend on a cost comparison. Liquid carryover leading impossible to burning rain is more likely with a vertical stack. The one issue, burning rain. Let us see what is that. Gas flowing to the flare open contains entrained liquid, particularly during an emergency shutdown. Emergency blowdown. No. If liquids are allowed to blow up in the flare, they will catch the fire, come down as a burning rain, creating a very hazardous situation around the base of the flare, or sudden release of excess gas or more gas than the design capacity. Burning rain is particularly dangerous on a platform due to the enclosed space. Despite this, some of the early platforms featured vertical stacks. One more system we have to discuss before winding up the flare system details. It is ignition system. Keep up the flame burning. How we can ignite the flare. All onshore and offshore flares are equipped with strategically located ignition and continuous pilot. There will be a pilot will be there with the flare system continuously providing the low flame system to support the main flame, ensure the flare is ignited immediately, there is a gas release. Pilot burners are provided to ensure a continuous ignition source at the flare stack. The ignition consists of multiple pilot burners arranged around a flare tip, supplemented by a remote controlled pilot ignition system to ensure against flame failure. So it will make sure that continuous ignition, continuous low flame will be there. So the main release will come. So that will improve or increase or catch the main release system. Typical ignition systems are flame front generator and the electronic. Two type ignition systems are available. Flame front generator and electronic ignition system. Electronic ignition system eliminate the need of a flame front generator by introducing a spark within the pilot nozzle. They can be configured for either manual or automatic operation. So this is the flame front generator. So we are creating here itself a combustion mixture with the air and hydrocarbon, then firing from here itself, and the fire itself moving as a fireball. It is going here and maintaining the fire here. So that system is a flame front generator. A flame front generator is a system which air gas mixture is introduced at ground level. See, ground level, and flows up a 1-inch line to the pilot burner. This is the pilot burner. You can see here. See, this is the main burner tip. You can see here pilot burner. After filling this line with the mixture, it is ignited by a spark here itself, creating a spark and the fire starting from here. The resulting flame travels to the top of the flare where the pilot burner is ignited. See, the resulting flame, that means the fire is traveling here. This location, fire is traveling here. So this is that flame front generator arrangement in ground level. So you can go and operate either automatic or manual. You can do the maintenance here as well. During the operation, the flow of fuel gas is established through the system, and the flame front generator, flame front line is first purged, then filled with gas and air mixture. The mixture in the combustion chamber, here the combustion chamber will be there, is ignited by a spark and the flame front initiated. So it is working, started in operation. The flame front fireball, that is important, travels to the pilot tip where it ignites the pilot. So it will be traveling from here. The great advantage of the compressed air flame front generator is that the flow controls and sparking device at the grade and can be serviced while the flare is operation. You can service here where flare is in operation. System can be fully automated and manual. Another one is electronic ignition system. No flame front generator. We are making a spark from the bottom and it will, in the flare tip or pilot flare, it will ignite. Electronic ignition systems eliminate the need of a flame front generation by introducing a spark within the pilot nozzle. They can be configured for either manual or automatic operation. Electronic spark ignition of a flare pilot burner is simple and easy to automate, more frequently becoming the preferred flare ignition method. So more frequently also you can do. There are two basic forms of this system, high energy and high tension. I am not discussing in that one in detail. A capacitor is used to discharge the spark across a low tension spark plug in a short time with a high current. Pilot flame monitoring is achieved through the use of thermocouples. Thanks for watching this video. The flame system is getting finished by this video. So 2 videos only for flare system. Hopefully we can find a new subject from our incoming videos. So definitely we will make another video soon. Thanks for watching this video. Have a good day.